In this video, we are going to learn about the inverse trigonometric functions. So we're going to mainly focus on the sine inverse function and the cosine inverse function and tan inverse function. We can talk about the other three inverses later. So first, let's focus on the inverse sine function. So inverse sine function. So let's to learn the inverse sine function, we can look at the sine function first. So so it has a graph like this. So if you look at these graphs, so what we can see, so we can see that in general, this is not a one-to-one function, because that's very clear from the horizontal line test. So if you draw a horizontal line, and you can see that in certain places it's going to cut more than once. So what we're going to do, we're going to pick a special domain. We're going to restrict the domain so that it's going to be one-to-one. So that means there are several ways to define the sine inverse function, but what we normally try to do is we try to stay close to zero. We try to stay close to zero, and then also try to pick a full range. So what we're going to do to stay closer to zero, we're going to pick the part from here all the way up there. So this is the part we're going to pick. So that means if we restrict the domain only to this part, just to get this part, that means is from negative pi over 2 to pi over 2. So just this part, that's the domain. You can see that if you pick only this part, then on this part the function is one-to-one. Sine function is one-to-one. So since the sine function is one-to-one on this part, we know that if a function is one-to-one, then the inverse exists. So we can use that idea. So that means we can see that on x going from pi over 2 to negative pi over 2 to pi over 2, you can see that the y equals sine x. So the sine x function is one-to-one. Since the function is one-to-one, then you can define the inverse. So the inverse exists. So thus the inverse exists. Inverse exists. So that means what we're going to do now, we're going to use the special domain, and then we're going to find the inverse using the the standard procedure. We replace x and y, and then we switch x and y, and then solve for y. So that's what we're trying to do. And also we can look at the shape of the graph, like how it's going to look like later. So let's try to define the inverse function now. So we can use the standard method to find the inverse function. So what we normally do is we can start with y equal sine x, and then we can replace the two variables. We can write this one as x equal sine y, and then you can see that this is actually the inverse function in the implicit form. So what we can do, we can write this one in a different form. We can write this one as y equal, so if this is the case, if x equals sine y, we can write this one as y equal sine inverse x. So this is what we normally call the explicit form of this function. And then the assumption is, because since we only pick the domain as negative pi over 2 negative pi over 2 to pi over 2, what will happen when you try to find the inverse function, the y value end up in that exact same range. So that means x is inside that range. So this is where the y is defined, because that's how we pick the domain for the sine function. That means when you find the inverse, we get the domain because it's going from y to x. So you get the domain. So here, so this is the special part that we remember, because otherwise the sine can take different values, but we restrict the domain, and so that we're going to get that value. Also, you may see that the sine inverse x is actually an angle. So this is an angle. So what it means, so how we find this angle? So we can see that this domain is actually where the sine, the cosine is positive. You can see that on this domain, the cosine function is positive. So that is how we find uh, the um, the range of the sine inverse function. So the values of sine inverse we pick so that the cosine is positive. Good. So let's write the definition now. So the definition uh, is, so we can say y equal sine inverse x if x equal sine y. So that means we know that sine inverse x is an angle. So we're going to find an angle so that we're going to say y equals sinus if x equals sine y under the condition. So we're going to see where we have several conditions where x has to be in between -1 and 1, and the y has to be negative pi over 2 and pi over 2. So that's how we define the sine inverse function. So that's the definition of the sine inverse function. So let's try to look at the graph of these two functions. So we already graphed these two. So this is the sine function only on that special domain. So that is going from negative pi over 2 to pi over 2. So it's going to start at -1 and go all the way up to 1. So that is the sine function. So we normally use the x variable and the y variable. So if you use the same variable, so this is the y equals sine x function. So if you graph sine inverse x, so what happened? So you just reflect the two axes. You reflect the two axes x and y. And then so once you do that, so we'll end up getting a sine inverse function like that. So you can see it's going to go like that and going to go like this. So that is the sine inverse function. But these two are in between, so you're going to plug in a value now. So this is -1 to 1 now. Those are the x values, and then you end up you get angle. So it's going to be pi over 2 and negative pi over 2. So this is the so now we're going to use the same variable y and x. So if you use the same variable, so this is the y equal sine inverse x function. Good. So those are the two graphs, the sine graph and the sine inverse x graph. So you can see one start at pi over 2 to pi over 2 and get values between -1 and 1. The other one start at -1 and 1 and get values in between pi over 2 and negative pi over 2. So those are the two graphs. And then when you try to solve problems, and I'm going to write like a small note. So you can see that from these two graphs we can write, we're going to make a short note. So the first one is you can see that the sine x is a value. This is just a value, a number in the interval -1 to 1. So you get values in the interval -1 to 1. And the second one, sine inverse x, is an angle. So when you see sine inverse x is an angle. It's an angle in the interval negative pi over 2 to pi over 2. And then the third one, it's also important to say that y equals sine inverse x is an odd function, So all these are very useful when you want to find the inverse functions, and we're going to use all of them. And also the common trigonometric values play a big role when you try to find the inverse functions. So let's look at those values now. So these are the common values. So we discussed this table earlier. We normally have the values for 0, pi over 6, pi over 4, pi over 3, pi over 2, and pi. And then those values are given by 0, 1/2, 1 over square root 2, square root 3 over 2, 1, and 0. And you remember how we get those values? We can write these numbers 0, 1, 2, 3, 4, and then take the square root. and then divide by 2. So you can see those are the values in the sine row. So again, what we write 0, 1, 2, 3, 4, take the square root and divide by 2. Once you simplify, you can see you're going to get, so this is simply 0, this is 1/2. This you can write as 1 over square root 2. This is square root 3 over 2. You don't need any changes. This is 1. So those are the values in the sine row. So what are the values in the cosine row? The cosine row values simply you reverse them. So that means you can write 1 and then square root 3 over 2. This stays the same. 1/2 goes there, 0 goes there. And then to get the tan values, we divide the sine value by cosine value. So that means you're going to get 0, and then you're going to get 1 over square root 3. The values are the same, you get 1. This is going to be square root 3. And then you can see it's 1 over 0 is a division by 0. So that means in general it does not exist, but in some practical situations you can see we write this as plus or minus infinity depending on the situation. And to get the values of pi, we have to use the unit circle. So we can use the general definition for sine. Sine is y over r, cosine is x over r, tan is y over x. So we can use those three definitions to find those three. So that means sine pi means y coordinate, which is 0, because pi means this angle. So you're going to find the y coordinate, which is 0, and then the cosine is x coordinate. So that means which is -1, and then when you divide you get 0 for tan. Okay, so those are the common values, and we're going to use, so this is the major help or the key to find the inverse trig function value. So please remember this table because this can help you a lot, and we can see we can use this in many times. So let's try to look at some problems now. So let's do this as the first one. So let's say find the exact values of, so we're going to refer to the table. So what it says that what is the value of sine inverse 1 over square root 2. So what it's asking an angle, because we know that the sine inverse means an angle. So you're looking for an angle. Once you find the sine of that angle, you get 1 over square root 2. And from the table, you know that the angle is pi over 4. So that is the answer. So this is since sine pi over 4 equal 1 over square root 2. So it's very clear. So let's look at the second problem. So let's say sine inverse -1/2. So if you get a problem like that, so one way to do this is, we know that sine inverse is an odd function. So we're going to pull the negative sign out. We can write this one as sine inverse 1/2. So if you pull the negative sign out, and then from the table, we know this value. From the table, sine inverse 1/2, that means the angle corresponding to 1/2 under sine is pi over 6. With the negative sign, it becomes negative pi over 6. So that is pi over 6. So that is one way to do the problem. The other way to do the problem is we can actually think of a value in the range. So, or you can directly say, so sine inverse a -1/2. So it's a negative value. And then from the graph, it's clear that if it's a negative value, you should have a negative angle. And then the angle is simply corresponds to, so you are thinking of an angle in the between negative pi over 6 and 0, so that once you take the sign you get the -1/2, and it's clear that it is the negative pi over 6 angle. So you can directly write it like that. So it's up to you which version you're going to go, but for the second version you need to think about the graph. The first one we use the odd function property. So this is an odd function. So odd function, okay, odd function property. The second one we use the reason of the sine inverse function, because we know that the sine inverse function have a shape like that. So that means we look for the value. You can see the value is a negative value. So once it's a negative value, you should get a negative answer. So that's how we get the negative pi over 6. Good. So let's look at the next one. So as the next one, we can have a sine inverse pi. And you can see that, so we try to find sine inverse pi. So that means you are trying to find an angle. Once you find the sine of that angle, you get pi. But we know that the range of sine is always in between -1 and 1. But pi is more than 1. So pi is approximately equal to 3.14. So that means there's no such value. There's no angle that's going to give you anything more than 1. That means this is we can say undefined. So there's no such value. So this is undefined. So if I ask you to find this value, there's no answer for that. And then so there are certain values, like for example, if I say find sine inverse 1/3. So if I ask you to find sine inverse 1/3, the thing is that that is not a common value in the table. So what we're gonna do, we're gonna use an approximation, and we use a calculator to do that. So we can use a calculator. So we can give the exact value for this. Use a calculator and then find this value. So you will get up to 3 decimal places. You're gonna get 0.3398. And then we can do another one. So for example, sine inverse -1/4. So you can directly you plug in this value to the calculator, and also you want to make sure that when you plug in those values like that, you want to make sure that it's in the radian mode. So you have to be very careful. These values we're going to use the radian mode to get these values. Actually all the values, but especially if you have these numbers that are not coming from the table, you want to make sure that you use the radian mode, otherwise you get wrong values, which might consider degrees and get wrong values. Okay, so here the first thing that you can do is since this is an even function, we can pull the negative sign out. You can write that this one sine inverse 1/4 and then use a calculator and get the value, or you can directly plug in sine inverse -1/4. So it's up to you. So you're gonna get something close to -0.25227. Okay, so that's how you find several sine inverse values. So let's look at the inverse property of the sine inverse function now. We're gonna look at the inverse function properties now, and we know that earlier when we have the inverse function, we learned that the f inverse fx equal x for any values x in the domain of f, and also we learned that f of f inverse x equal x for values x in the domain of f inverse. So we can use the same idea for sine inverse function now. So that means we can write sine inverse sine x equal x for any x in that special domain. So that means x has to be between -pi/2 to pi/2, because that is the function, that's a one-to-one part of the function. And then we have sine x, sine inverse x equal x. So that means it looks like they cancel each other. But if x is in the right domain, and the same thing happen, it looks like cancel out if x in the right domain. In this case, x has to be between -1 and 1. So this is one of the interesting property, and that will be very useful when you try to find several sine and sine inverse combinations. So and then what we're gonna do most of the time, we're gonna use the reference angle method to find. Reference angle method will be helpful in this situation. So the reference angle method. Reference angle method will help. The reference angle method. So so let's try to look at some problems, and it will be clear what I'm talking about here. So let's do these problems. So the example, find the exact value of value of, find the exact value of, so the first one, sine inverse sine pi over 12. And what you want to know is this is one of the identity, and you want to make sure that pi over 12 is inside the range. And you can see that pi over 12 is actually in the range of the in the domain of the function. So you can see pi over 12 is inside. So that means according to the last result, this is simply this value. So you're gonna it's an inverse function property. You can come back to the starting value. So that's it. And the next one, so let's say this problem, let's say we have sine inverse sine 7 pi over 12. So if you look at this angle, and you can see that this is not in the domain, it's outside of the domain, because this angle is somewhere here. This is the third quadrant. So since this angle is in the third quadrant, because it's 7 pi over 12, because if you have 6 pi over 12, it is exactly 90, but it's a little bit more than that. So that means in the second quadrant, that means we need to find the reference angle. So what we normally do, if you get a problem like that, we're gonna try to find an angle, because we can rewrite this. This is a value. We can write this one using the reference angle method. So when you use a reference angle, remember what we're trying to do is we try to find the theta r here. So theta r is the difference between the angle and the x angle. X angle means angle is on the x-axis. So so that angle is pi. So what we normally do is we can write multiples of the denominator. So this is 12. So it's like 12. So 0 and 12. Those are the multiple of 12. So that means since we get 12, the reference angle, because since we have 7 here, this is 12. So the difference, so it's a fraction addition. What we're gonna do? So that means it is 12 over 12 minus 7 over 12. So that means 5 over 12. So that means the angle is 5 pi over 12, because this is just a fraction. So that means what we can do is we can write this one like this. This is simply equals to sine sine inverse sine the reference angle, which is 5 pi over 12. But now you can see that this is a angle inside the domain. Okay, inside the domain. So that means according to the inverse function property, you can see that this is simply equal to 5 pi over 12. So again what we did, so if we get a problem like that, first we check whether this angle is inside the standard domain, negative pi over 2 to pi over 2. If it is not, what we're going to do, we're going to use a reference angle method. So what's the reference angle method? We try to find the reference angle corresponding to that angle. So once you know the reference angle of that, so in this case, since the denominator is 12, we write multiples of 12. So that's why that 0, 12. 12 means it is 12 over 12 minus 7 over 12. So it's a 5 over 12. That means the angle is simply 5 pi over 12. So now when you have 5 pi over 12, reference angle is always in between 0 and pi over 2. So that means that's nicely work with the inverse function property. So you get the answer as 5 pi over 12. Okay, good. So let's try to do another one. So how about this? So let's say C sine inverse sine 4 pi over 3. Okay, so if you look at this angle, and then you can see that this angle is in the third quadrant. This is in the third quadrant. That's the angle. So this is the so it's a 3. So we have 0 and then 3. So that means, so we have 3 over 3, but it's gonna go one more, because you can see that this is 3 over 3 plus 1 over 3. That's how you get 4 over 3. That's how you get 4 over 3. So it's just one more. Since it's one more, the reference angle can be pi over 3. So that means this is simply equals to You can see that, and this is also in the third quadrant, and but that is a sine, so it is a negative. So that means we can write this one as sine inverse negative sine the reference angle. Now, since the sine inverse function is an odd function, we can pull this negative sign out. So you can write this one as negative sine inverse sine pi over 3. Now you can see that this angle is actually inside the domain, because pi over 3 is in the domain pi over 2 to negative pi over. That's always happen when you use a reference angle method. That means you can cancel out, so you're going to answer will be negative pi over 3. So that's what you get as the answer. So and then you can see these three problems actually cover the three methods that we normally use. So if you understand these three problems, you can do all the problems of this type, because these are the only three methods that we're going to use. The reference angle direct, so first one is the angle is inside the domain, so it's clearly, so we're going to cancel out and get the angle. The second one is a reference angle method. We find the reference angle, so the reference angle comes out. And then because the sign is in the second quadrant, it is positive, that's why we're going to get like that. But in third example, you can see that it's in the third quadrant, and according to ASTC, sign is positive only in the first two quadrant, but this is the third quadrant, so since the third quadrant sign is negative, so that's why it is negative sine pi over 3. But sine inverse is an odd function, so you pull the negative sign out. So it's a negative sine inverse sine pi over 3. Now, by the inverse property, you can this sine inverse sine get cancelled, so you get negative pi over 3. So those are the three major examples of this problem. So you can try this as an exercise. So why don't you try this as an exercise? Let's say, for example, what is sine inverse sine, let's say sine 13 pi over 7. So you should get negative pi over 7 as the answer for this one. So as the final problem, let's look at a problem like this. Let's say we have sine inverse cosine 2 pi over 3. So in this problem, you can notice that these two functions are different. So what we're going to do, we can evaluate the inside function. To evaluate the inside function, and you can see that that is in the second quadrant. So this is in the second quadrant, 2 pi over 3. So the reference angle is pi over 3. So that is pi over 3. That's the reference angle. So and also you can directly calculate cosine pi over 3 like that. So that means this is simply sine inverse x, we repeat it, and then cosine 2 pi over 3, so that's equal to negative cosine the reference angle. From the table, cosine pi over 3 is 1/2, so this is simply sine inverse negative 1/2. So sine inverse is an odd function, so if you pull it out, so you can see that this is a negative sine inverse pi over 3. 1/2 is pi over 6. Is sine inverse 1/2, so not pi over 3. So sine inverse 1/2. So that means it is, so you're gonna get this one as negative pi over 6 as the answer. So you pull the negative sign out because sine inverse is a odd function, so you pull it out. Okay, so let's do the other type. So let's do this one. Find the exact value of, so let's do the first problem like this. Let's say sine inverse. So now we have the inverse inside. So let's say 1 over square root 2. So that means you know that when you do that, sine inverse is an angle, so you get an angle first and then we find the sine of that angle. But the theory says that if you have inverse functions, from the inverse function property, if this number is in between 1 and -1, then this is simply equal to the number itself. So that means this is simply that, because this is inside -1 and 1. So it's very simple. And then B also we have sine. Let's say sine inverse, let's say -0.123, something like that. And then again the same thing, we want to check whether this number is in between -1 and 1. So yes, that's the case. So yeah, so this was in between -1 and 1. So that means this is simply -0.123. So you get the exact same number. And then as the last one, let's say sine inverse pi, something like this. And you can see that this pi is not inside that interval. That means sine inverse pi is not defined. There's no angle that's giving sine inverse pi. So that means this is undefined. So this is undefined. This is undefined. Okay, this is how you do problems. So once you understand these problems, and you can see that it's very similar when we try to talk about the cosine inverse and tan inverse, you can see they are very similar to what we did here. So we can discuss those two now, cosine inverse and sine inverse. So next we're going to go to the inverse cosine function. So again, we look at the graph of the cosine function. So we have this one. So so we have x and y. So this is the cosine function. Now the question is which domain we're gonna pick. So as we discussed earlier, we try to find a domain. We try to restrict the domain so that the cosine is a one-to-one function, and then try to stay close to 0 as much as possible. So that means if you want to do that, then we can probably go from here to all the way down to that. So you can see this one contains a full range and also stay close to 0. So that is the part we're going to pick as the cosine function to find the inverse and to make it one-to-one. So this part. So going from 0 to pi. And once you do that, and then you can see, you can also graph the inverse function now using this one, switching the axis. So you're going to get this one as the inverse function. So this is the x and y, also change the variable, and so it is simply this. So that is the cosine inverse function. Doesn't look good. Yeah, so we're gonna get this. So go from -1 to 1, and you can see the values range from 0 to pi. So this is pi over 2. So that is the graph of the cosine inverse function. So this is y equal cosine inverse function, and you can see it is the same thing. You just switch the axis and draw it. So this is pi over 2, and you can see this is simply this part by switching the axis, and you can draw it like this. Good. So then we can write the definition. So the definition is we can say y equal cosine inverse x if x equal cosine y. So so that's the definition, where we have x is inside 1 and -1, and y is in between 0 and pi. So that means the range of the cosine inverse function is from 0 to pi. So this we consider as the definition of the cosine inverse function. So let's do some problems to see how it works. And also you can see that the domain that we pick is where the sign positive. So you can see on this domain, you can see the sign y is positive on those. So that's the domain we pick for cosine. That's where the sign positive from 0 to pi, sign positive. So that's the region we pick for cosine. For sine inverse, we pick the domain where the cosine positive. For cosine, we pick the domain where the sine positive. Good. So let's look at several examples to see how we can use this idea. So the first one, So find the exact value of, so the first one is cosine inverse 1. So you need to think of an angle which gives cosine uh, equal to 1, and you know that that angle is 0 in radian. So because this is since cosine 0 equals 1. So if cosine 0 equals 1, we write it as the inverse function, switch in the numbers. So B, so let's do a little different problem. So let's say cosine inverse, I'm going to start here. Cosine inverse, let's say negative square root 3 over 2. So, so when you get a negative value, so what can happen is, you can see, so it's not a positive value, it's a negative value. So negative means in the domain where, so we are looking for the domain only in these two domains. So there, and you can see that if in the second quadrant, it is negative for cosines, because we know that the cosine negative in the second quadrant. So that means what we're going to do, so that means we know that this angle is in the second quadrant. So that's another idea. So we know that this angle has to be in the second quadrant. So that means we can write this one as like this. We can say this is equal to pi minus the reference angle. So we're going to say this is pi minus cosine inverse square root 3 over 2. So this method works for any problem like that. If it's a negative number, it has to be in the second quadrant. So it's always pi minus the reference angle. And then you can see this is very easy to calculate. Now it is pi minus cosine inverse pi over 2 from the table. It is pi over 6. So that means the answer is 5 pi over 6. So that's the angle we are looking for this one. And then, so let's do this one. Let's say cosine inverse E. But you know that E is approximately, so E is approximately 2.718. So it's more than 1. That means this is undefined. There's no such value. Okay, so let's talk about the inverse properties as before. So from the inverse properties, we can write these two relations. So cosine inverse, cosine x equal x. If x is in the proper domain, so that means it is 0 to pi. That's the domain we pick, so that the function is 1 to 1. And then the cosine x is equals to cosine inverse x, which is equal to x. Cosine inverse x equal x. So this all works when x is in between 1 and -1. So that's the easy one. So these are the inverse properties. So let's try to do some problems that use this idea. Find the exact value of A, cosine inverse cosine pi over 7. So this is a cancelling property, and then you only need to check whether this is in the domain, and you can see that this is in between 0 and pi over 7. That means this simply equals to pi over 7, since pi over 7 is inside in the interval 0 to pi. Again, the next one, we check whether this number is in the interval from 0 to pi, and you can see that yes, it's in between. So that means it's also going to be 2 pi over 3 for the same reason. So since 0 less than or equal 2 pi over 3 less than or equal pi. And when you look at the next example, and you can see that negative 2 pi over 3 is not in the domain from 0 to pi. That means we cannot do it like this. So what we can do, there are two ways to do this problem. So the first one is you can actually calculate the inside function. So you can see this angle is in the it's a negative angle. So so that's the angle. So it's gonna go. So this is negative 2 pi over 3. So you look at multiples of 3. So that means the reference angle is pi over 3. That's a reference angle. So that means this is simply, we can write this one as cosine inverse. So you find the reference angle is in the second, actually it's in the third quadrant, so it's a cosine which is negative. Reference angle is pi over 3, so that means this is simply negative cosine pi over 3, negative cosine pi over 3 using the reference angle method. So this is now going to be cosine inverse negative 1/2 from the table. Pi over 3 is 1/2. Now we're going to find cosine inverse pi over 3. So this is a problem similar to what we just did in the previous one. So you can see it's a negative number. It should be pi minus cosine inverse 1/2. So that means it is pi minus pi over 3. So it is 2 pi over 3 if you simplify. So so that's the answer you're going to get using the first method. First, so what we did, we try to evaluate the inside and then you look at the inverse function. So and then let's look at the method 2. From the method 2, we're going to use the property that the cosine is an even function. So if you use the property that cosine is an even function, so this is cosine negative 2 pi over 3. Since it's an even function, we can disregard the negative sign. So we can write this one as cosine inverse cosine 2 pi over 3. Now you can see this is very similar to part B. So that means this is simply because this angle is inside between 0 and pi. So this is between 0 and pi. That means this is simply equals to 2 pi over 3. So that's the second method. We use the even function property for the cosine. Good. So let's do another one. So we can have cosine the different type. So cosine inverse negative 0.3, and you can see that the negative 0.3. So now this is the other way, other type. So that means we need to check whether this number is in between negative and 1. So yes, it is negative between negative 1 and 1. So that means the answer is simply the number itself. And then E, we have, let's say, cosine inverse sine 5 pi over 3. So this problem is slightly different from the previous one. So since we have two different functions, so what we normally do is we try to evaluate the inside function. So this is sine 5 pi over 3. So let's see where this angle is. So this angle is in the, you can see it's a fourth quadrant. So this angle is in the fourth quadrant. So this is 5 pi over 3 because it is 0, 3, 6. So it's closer to 6. So it's only missing pi over 3. So that's a reference angle. That means a negative sine pi over 3. So they're going to get cosine inverse. We rewrite it. And inside is going to be negative sine pi over 3. So, so this is pi over 3. So, so sine pi over 3 is square root 3 over 2. So that means this is cosine inverse negative square root 3 over 2. And then we can find this one as we did. Actually, we calculate this one in the previous section. So we get 5 pi over 6 as the answer. Okay. And then let's do one last problem of this type. So let's look at one. So this is cosine inverse cosine 7 pi over 3. So this is in the first quadrant, because the reason is you can see the numbers are 0, 3, 6. So it is only one more. That means it is in the first quadrant. Since it's in the first quadrant, the inside function is simply cosine pi over 3 because in the first quadrant. That's a reference angle. So cosine pi over 3 is 1/2. So that means this is simply cosine inverse. Also, actually, after we get to this level, then what you can do is you can use the cancellation property. You can see that this angle is in the domain. So you can cancel out and then you can get pi over 3. So you have to do that when this angle is not inside the domain. Uh, so that's how you solve certain problems for cosine. So let's do the last part, tangent. So it's an inverse tan function. First, we are going to look at the graph of the tan function. So we have this one. Tan function has asymptotes. So we have an asymptote at pi over 2, negative pi over 2 and pi over 2. So this is pi over 2, negative pi over 2. So the graph has this shape. The special values are at pi over 4, it is 1. So that is one of the major value, and similarly for the negative pi over 4, it is negative 1 because it's an odd function. So this is the graph of tan. Now switching the axis, you can get the inverse tan function. So we have the inverse tan function like this. The vertical asymptote now become horizontal asymptotes, and the graph gonna take the form like this. So the values, these are pi over 2 and negative pi over 2, and it goes from negative infinity to positive infinity. So this is the y equal tan inverse x. So this is y equal tan x. So we can write the definition as before. So we can say y equal tan inverse x if x equal tan y. And we know that the tan one period is going from negative pi over to pi over 2. So that means when the tan moves from pi over 2 to pi over 2, you can see tan ranges from negative infinity to positive infinity. That means it can carry all the values from negative infinity to positive infinity. So that means, so where we have x is in between, not including infinity and negative infinity, positive infinity, negative infinity, and you can see y ranges from pi over 2 to negative pi over 2 to positive pi over 2 without the corners. So it's easy to remember when you talk about the sine inverse, y is going from negative pi over 2 to pi over 2 including the corners. When you talk about tan inverse, it is from pi over 2 to pi over negative pi over 2 to pi over 2 without the corner. So that's the difference between the two, and this is the tan inverse function. So let's look at some problems and how to use this, and also the inverse function property that we can discuss later. So let's look at some problems. We also have a small note about the tan inverse function. As sine inverse, tan inverse is also an odd function. So y equal tan inverse x is an odd function. So this will be very useful when you try to solve certain problems. So let's look at the first one. Find the exact values of the first one. Let's say tan inverse 1. So what we're trying to do, we try to find an angle. Once you find the tan of that, you should get 1. So from the table, it's clear that it is pi over 4. Since tan pi over 4 equals 1. So let's do the next one. Let's say tan inverse negative 1 over square root 3. So tan is a odd function. We pull the negative sign out. So you can write this one as tan inverse 1 over square root 3. From the table, it is clear that the angle is pi over 6. So it's a negative pi over 6 because it's negative. And then, so as the next one, let's do tan inverse 2. Actually, we cannot find exact values of this one because it's not one of the values from the table. So what we're trying to do is we're going to use the calculator and make sure that it is in the radian mode before we do that. So in the radian mode and using a calculator, so you can see that you're going to get 63.43 radians approximately. Okay, so next we can look at the inverse function property. From the inverse property, as before, we can write this one as tan inverse tan x. So this is valid when x is in the domain from negative pi over 2 to pi over 2, and then tan inverse x equal x. This is true for any value from infinity to infinity. So it can be anything, and you get this one. So these are the two properties for the inverse tangent function. So let's try to see how we can use them in several problems. Find the exact value of, so let's do tan inverse tan pi over 8. So we just need to check whether this is in the domain, and you can see that that's clear in the domain. So this is pi over 8, since negative pi over 2 less than pi over 8 less than pi over 2. So the next one is tan inverse, let's say tan 2 pi over 3, and you can see that 2 pi over 3 is not in the domain. So that means we need to find the reference angle method. So we're going to go with we try to find this value first. So you can see this is in the second quadrant. This is second quadrant, so this is 2 pi over 3. So the reference angle is pi over 3. And it's a tan, so it's a negative value. So we can write this one as tan inverse negative tan, the reference angle. Now, since this is a odd function, we're going to pull the negative sign out. So we can write this one as tan inverse tan pi over 3. Now you can see that this is actually in the domain. This angle is in the domain, so the answer is negative pi over 3. So the interesting part is you can see that these two angles are not equal to each other. So you get a different answer when you try to find them. Okay, so let's do part C. So let's do tan inverse 13, and you can see that this identity true for any value. So that means this is simply going to be 13. So that's the easy part with tan inverses. And then as the last one, we can try tan inverse cosine 5 pi over 6. So you should be able to do this right now. So there are different types now. So what we're going to do is we're going to find the inside value first. So look for the angle, and you can see that this angle is in the second quadrant. 5 pi over 6. Why we say second quadrant? You can see it is a multiple of 6. So it is 0, 6, but it's 5. So that means it has to be in the second quadrant. The reference angle is pi over 6. So the reference angle is pi over 6. So this is simply tan inverse. So this is cosine is a negative. So negative cosine pi over 6. So that means this is tan inverse. Negative pi over 6 means square root 3 over 2. Now this is not a value in the table because for tan. So what we can do is we can use a calculator to find this value. So and then also this is a negative number. It's a odd function. You're going to pull the negative sign out. So you're going to say tan inverse square root 3 over 2, and then we can use a calculator and approximate this value. From a calculator, you're going to get this as negative 40.89 as the answer. Okay. So in summary, what we have, because of the odd function property of sine inverse and cosine inverse, you can simply write this negative sine inverse sine negative alpha as just negative alpha, and tan inverse tan negative alpha as negative alpha if alpha satisfies the domain. That means in between negative pi over 2 to pi over 2. And for cosine, if the cosine is negative, so after what we can do is always become pi minus cosine inverse alpha. Here alpha is a reference angle. So this is something you can use for most of the time. So I mean, if it is the second quadrant, you really don't need that. Then you just get the theta as the answer. But if in the third quadrant, this might be useful. So this is something that you can use when you solve problems. So this is about the how to solve, how to find the inverse trigonometric functions. This is very important one because we can use this idea again and again in many other sections.